Hi, this video is about how to use a spectrophotometer. It's a really important instrument that you use in science. But first of all, what is a spectrophotometer? Well, it's an instrument that's going to measure the amount of light of certain wavelengths which passes through a sample. So let's see how this works. So we're going to watch another little video here that explains how it works.
Here's how a spectrophotometer works. A lamp provides the source of light. The beam of light strikes the diffraction grating, which works like a prism and separates the light into its component wavelengths. The grating is rotated so that only a specific wavelength of light reaches the exit slit. Then the light interacts with the sample. From this point, the detector measures the transmittance and absorbance of the sample. Transmittance refers to the amount of light that passes completely through the sample and strikes the detector. Absorbance is a measurement of light that is absorbed by the sample. The detector senses the light being transmitted through the sample and converts this information into a digital display.
Okay, so that is how a spectrophotometer works. But here is our spectrophotometer. It looks a lot different from the one that you just saw. It's just a tiny little spectrophotometer that we're going to connect to our computer, and our samples go in these little cuvettes, and they're going to go right in here into this spot, and then within a second it is going to give us the following spectrum. It's called an array spectrophotometer because it will measure wavelengths from, I think it's about 360 nanometers up to about 900 nanometers. And it will send all those different wavelengths of light and record the absorbance of light at all of those different wavelengths and then give us a graph that looks like this. Well, absorbance has no units, but it's still a measurement. And so I wanted to just show you another little animation of absorbance in case you missed it in the last one. Okay, so here we go. This is going to be our sample, and it is green in color. And here's our light source, and over on the right-hand side is our detector. So we're going to see these little purple dots coming from our light source. So those are photons of light, and they're about to hit our sample. There they go. So they're hitting the sample, and then they're coming through the sample and heading to the detector. But if you notice, some of those photons of light are getting absorbed in the sample, and they're not winding up on the other side of the sample, and so they're not being detected. And so we would say that our sample is absorbing some of that light, and that's what our detector is telling us. Alrighty, so let's go on back. And this is a picture of a cuvette in our sample. You'll fill your cuvette about 3/4 of the way full. You want to make sure that your path of light, the entire path of light can go through your sample. And so your light is going in, and then your sample will absorb some of the light, and then the light will go out. All right, so uses of a spectrophotometer. Well, different substances are going to have a different absorption spectra. And so we can use this to identify an unknown sample. You can compare your unknown sample to samples that you know, and you can compare their absorption spectra. So here we've got red food coloring. This is the structure of red food coloring. And here's our graph. The y-axis is absorbance, and our x-axis is wavelength. And so our spectrophotometer was shining light, and it started down here at like 350 nanometers, and nothing much was absorbed, not much was absorbed, so most of this light was going through. But then when we got to a wavelength at 524 nanometers, our sample really absorbed that wavelength of light. And then the spectrophotometer continued with other wavelengths of light, and not much of that light was absorbed. So what we can say is that our red food dye was absorbing light at 524 nanometers. That is where there was the maximum absorption of light. So we call that lambda. Remember our Greek letter, the abbreviation for wavelength, our lambda max, where our sample absorbed the most light was light of a wavelength of 524 nanometers. Well, here's a different spectrum. It's for bromophenol blue. It's a dye that's commonly used in biology. Probably used it last year. And you can see that this spectrum looks a little bit different. Here, the lambda max would be about, I'm going to say, about 600 nanometers. And so different dyes will absorb wavelengths of light differently. All right, so what are we going to do in our lab? Well, we're going to determine the wavelength of maximum absorbance for different food dyes. And then I'm going to give you an unknown and ask you what food dyes made up that unknown. And you're going to do that based on its absorbance spectrum. So this lab is what we call qualitative. You're just going to identify something where it's not going to be quantitative where you tell us how much. We'll do that another day. All right. Well, we should have fun in this lab. Bye.